In this lecture, we are going to discuss about some more example on analytic function. So that the function fz equal to u plus I v, where fz is given by x cube 1 plus I minus y cube 1 minus I divided by x square plus y square when z is not equal to 0, and f of 0 is equal to 0 is continuous and satisfy Cauchy Reiman equation but f(0) does not exist. That is, fz is not differentiable. f(0) does not exist. Write the given function. Solution. Our given function is fz is equal to x cube 1 minus I minus 1 plus I, y cube 1 minus I divided by x square plus y square. This is the given function. Separate the given function into real and imaginary part. Write the real part with real part and imaginary part with imaginary part. Minus plus y cube by x square plus y square divided by x square plus y square. Here u is x cube minus y cube by x square plus y square, and p is my x cube plus y cube x square plus y square. Since u and p are rational function with non-zero denominator, so u and p are continuous. As every rational function, polynomial function, rational polynomial function is continuous at all points except at the x equal to 0 and y equal to 0, that is at the origin. So right, since u and p are rational function of x and y, rational function of x and y with non-zero denominator for all x and y except at x equal to 0, y equal to 0. To check continuity at x equal to 0, and y equal to 0, changing to polar. Sometime by changing the Cartesian coordinate to polar, our calculation become easy because it will reduce the number of step of computation. So changing to polar, changing u and b to polar, changing u and b to polar to polar by substituting x equal to r cos theta, y equal to r sin theta. We get u equal to r cube cos cube theta minus r cube sin cube theta by r square cos square theta plus r square sin square theta. Taking common r cube equal to cos cube theta minus sin cube theta divided by r square cos square theta plus sin square theta. This identity is 1. This r square cancel with r and it will be here r cos cube theta minus sin cube theta. That is my u is my, after changing to polar, u is my r cos cube theta minus sin cube theta. Sin cube theta which tends to 0 as r tends to 0, independent of theta. Similarly, b, if we change b to polar, then it is r cube cos cube theta plus sin cube theta by r square cos square theta plus sin square theta, and this is equal to r cos cube theta plus sin cube theta, and this tends to 0 as r tends to 0, independent of theta. Okay, and f of 0 is my 0. That means limiting value of fz and actual value of fz at z equal to 0 are same. So fz is continuous and continuous at the origin, therefore fz is continuous at all point, continuous for all value of z, right? Since limiting value of fz and actual value, limiting value of fz and actual value of fz at origin are same, are equal, therefore fz is continuous at origin. Therefore fz is continuous at origin. Fz is continuous at the origin. Since fz is continuous at all points except origin, we have already proved this here. Fz is a rational function. Fz is continuous for all value of xy except at origin. Here we have seen fz is continuous at origin. That means fz is continuous for all values of z. Therefore, fz is continuous for all values of z. Then next we are going to check out Cauchy Reiman equation. For that we will find out the partial derivative at origin. Next, at origin we are going to find out the partial derivative. That is del u by del x, that is limit x tends to 0 u x 0. Their point is my origin, so these are 0 0, increment is x, so keep x u is my this function x cube minus y cube by x square plus y square. Is it? Yeah, this one is u. So this is limit x tends to 0, x tends to 0. Here if I put u x0, this will be 0, this will be 0, this will equal to x cube by x square. So this is x. That means x minus 0. If I put 0, this will be 0, this. So this is limit x tends to 0 by 1, and this is 1. Next, partial derivative of u with respect to partial derivative of u with respect to y. So this is limit y tends to 0, u 0 y minus u 0 comma 0 divided by y. Here u is my this function x cube minus y cube x square plus y square. So if I put, so in next step it will be y tends to 0, limit y tends to 0, u 0 y. When I put x equal to 0, it will be 0, it will be 0, it will be minus y cube by y square. So this is minus y. u 0 y will be this one. So put this value here, it will be minus y, 0 0 will be 0, and it is y. This will give you limit y tends to 0 minus 1, and this is equal to minus 1. Next, check out the value of partial derivative of b with respect to x and y respectively. First is with respect to x, that is limit x tends to 0, b of x0 minus b 0 0 divided by x. Put the value limit x tends to 0, b x0. What is b? B is by x cube plus y cube by x square plus y square. Is it? Check it out. Yeah, b equal to x cube, b equal to x cube plus y cube by x square plus y square. So find out the partial derivative. It is equal to, if I put x equal to x, y equal to 0, it will be x cube. Again x cube by x square, and it is x, b, x0 is this one. So this, put this x, this is 1 will be 0, this is x. So put the limit x tends to 0, and it is 1, it will be equal to 1. Next again, find out the value of del b with respect to y. So this is limit y tends to 0, b 0 y minus b 0 0 divided by y. Here my b is x cube plus y cube by x square plus y square. If I check out what is the value of 0 y, put x equal to 0, it will be y cube, it is y square, that is y. So limit y tends to 0, y tends to 0, then it will be y minus 0, b 0 0 will be 0 0. So this limit y tends to 0, y by y, that is your limit y tends to 0, it is 1, so it is equal to 1. Now check out what is your equation. Now my del u by del x is equal to del u by del x. What is del u by del x? Del u by del x is my 1. It is 1, which is equal to del b by del y. Let me check what is the value of del b del y. It is 1. So next, what is the value of del minus del u by del y? What is the value of del u by del y? That is minus 1. Minus of minus 1 will be minus, then its value is minus 1. So it is plus 1, and it is equal to del b by del x. Check it out. What is del b by del x? It is 1. So from these two equations we will get it. get this one, del u by del x equal to del p by del y, and minus del u by del y equal to del p by del x. That means your equation are satisfied. Therefore, fz satisfies your equation. Satisfy your equation. Cauchy Reiman equation at origin. Cauchy Reiman equation at origin. Equation at origin. Next, we are going to check out derivative of fz at 0. By using the definition of derivative, we will get limit z tends to 0, fz minus f of 0 by z minus 0, that is z. This is equal to limit z tends to 0, fz is my x cube 1 plus I minus y cube 1 minus I. F of 0 is 0, so x square plus y square, then z. It will come here. In the next step, it will be, we can write here. So this will be my x square plus y square, x plus I y square. Put this equation 1. Next, taking z tends to 0 along y equal to x. We are going to check out whether this limit exists or not. If we take z tends to 0 along y equal to x, we get what we get? We get fx 0 is equal to, if I put y equal to x, then z is my x plus iy. Okay, if y is equal to x, then z is my x 1 plus I. Okay, as z tends to 0, x tends to 0. So here limit x tends to 0. Write this out. If we take x cube equal to y cube, then this y cube will become my x cube. Y cube will become x cube. Okay, so x cube minus x cube will cancel out. X cube minus plus, that will be my 2x cube I. Okay, divided by 2x square, that is y equal to x, then this is x square, this is 2x square, this will be x. So this will be my, if I take x common, this is 1 plus I. So this will be limit x tends to 0. Here it is cancel out 3, cancel this cancel with this one, this x, and this cancel with this one. I will left with I 1 plus I. So in next step, it will be I 1 plus I. To make denominator free of I, we will multiply it by multiply numerator and denominator by complex conjugate. Okay, so this is a square, this is equal to I 1 minus I, that is 1 plus 1, as I square is minus 1 plus minus 1, 1 minus 1 will be my 2. So this is I 1 minus I. Again taking z tends to 0 along x-axis, we get from this equation, we get, if we take now this step, it is It is along x-axis, that is y equal to 0. Along x-axis y equal to 0, this part will be 0, this will be 0, and this will be 0. This is x cube and this is x cube 1 plus 9. So that equation 1 becomes f x 0 equal to x cube 1 plus I. Here it is x square into x. So this is equal to my 1 plus I. Here it is limit x tends to 0. As z tends to 0, along x-axis y is equal to 0, z is my x plus I y. So z is equal to x. So x tends to 0. As z tends to 0, we have this x tends to 0. So put this value, we will get this one. Along x-axis, we will get this value. Since the value of f x 0 is along x-axis is my this value, and along y equal to x, along this is my this value, that is derivative is not independent of the path. Limit does not exist independent of the path. So right, since is not unique, it depends on the path, depends on the path, therefore f x 0, therefore f x 0 does not exist. With that, I would like to conclude. Remaining will be in the next lecture. Thank you.